Hello, class. This is the video for section 4.1, which talks about divisibility. Now, chapter 4 talks about number theory. And in this chapter, we'll be looking at what is divisibility, which is one. We're looking at least common multiples and greatest common factors and so on. So the learning objectives for this section are the following, just two. We're looking at the divisibility, what that really means, the notations or the symbols, the factors and multiples, and also the divisibility test for 2, 3, 4, 5, 6, 8, 9, 10, and 11. Now we start teaching divisibility from grade 2. And the State Common Core Standard states that students should be able to determine whether a group of objects up to 20 has an odd or even number of what members. For example, by pairing objects or counting them by twos. Write an equation to express an even number as a sum of two equal addends. And this is page 19 of the Common Core State Standards. Okay, now definitions of even and odd numbers. Okay, an even number is a whole number. Now remember, we are still talking about whole numbers. A whole number that has a remainder 0 when you divide it by 2. Okay, and if you express it as an equation, you have n is an even number, then you have what n is equal to 2 times q, and q is a whole number. For example, if 4 is an even number, we can write 4 is equal to 2 times what? 2 times 2. We know that 8 is an even number. We can write it as what? 2 times what? 4. And for, of course, in this case, q is 4. Over here, q is what? Is 2. All right. What about an odd number? It's a whole number. When you divide by what? 2, you get a remainder of 1. Okay. Writing it also as an equation, can write it as what? N is equal to 2 times q plus what? Plus 1. For example, we know that 5 is an odd number. So we can write it as what? 2 times 2 plus what? Plus 1. Okay. In this case, your q is what? Is 2. Or if you have 7, 7 is what? 2 times 3 plus 1. So 2 times 3 is what? Is 6 plus 1 is what? Is 7. In this case, your q is what? Is 3. All right. So the notation, when you have this notation, we represent that as a vertical line segment. That is D, the vertical line segment, and then A means that D divides what? A. That's how we read it. D divides A. And then if D doesn't divide A, okay, we write the same symbol, but we just cross it with, cross it like that. Okay, the fact we have for 3 divides what? 12, we can express it in 5 equivalent word ways. All right, we know that 3 divides 12, which is what? Which is 4, because 3 times 4 is equal to what? Is equal to 12. All right, now you can express it in 5 different ways. The first one is this, that 12 is what? Divisible by what? By 3. Or we can say that 3 divides what? Divides 12. Or we can say that 3 is what? Is a divisor. Okay, is a divisor of what? Of 12. Okay, or we can say that 12 is a multiple. Is a multiple of what? Is a multiple of 3. And then finally, we can say that 3, okay, 3 is what? Is a factor of what? Of 12. Okay, because if say 3 is a factor, of course, 3 times a number is equal to 12. Now remember, in the study guide, there is one question says that if you write this as 3, okay, we kind of stated it 5 different ways, and there's a list all possible ways that you can say that. All right, now let's go to some properties of what properties of division for what whole numbers. All right, now first one, now every number we're considering here are what are whole numbers. Okay, so for any whole numbers a b, we say that d divides a. Okay, and n is any whole number, then d will divide what that whole number times what times a. Okay, for example, we know that 4 divides what 8. Okay, so any multiple of 8 will also be divisible by what by 4. Okay, so we can also say that 4 will divide what will divide 16. Why? Because 4 divides 2 times what 2 times 8. Okay, or we can say that 4 will divide what 3 times what 8. That means any multiple, if 4 divides a number, or if a number divides another, that any multiple of that number will be divisible by the same word, the same number. Okay, that is the first property. The second property is that if d divides a and d divides what b, then d will divide what the sum of what a and b. All right, for example, we know that 4 divides what 8, and then also 4 divides what divides 4. So therefore, what will happen? What is what 8 plus 4? Okay, do you think that 4 will divide that? Yes, 4 will divide what 8 plus 4, which is 12, and 12 divides, sorry, 4 divides what 12, which is what, which is 3. Okay, so we say that if d divides what a number, and that same d divides another number, then d will divide their sum. Okay, that's what this means. The third property says that if d divides a and it doesn't divide b, then it will not divide what the sum of a and b, because d doesn't divide one of them. Example, okay, say we know that 4 divides what 4 divides 8. That is true, but we also know that 4 does not divide what does not divide 7. So of course 4 will not divide 8 plus what plus 7. Of course we know that 4 does not divide what 15. Okay, because if you add this, you get what you get 15. All right, so properties 1, 2, and 3 when it comes to division of what whole numbers. All right, now let's continue with the properties. The fourth one is that if d divides a and d divides what b, and then if a is greater than b, then the d will divide what the difference between them. Okay, so for example, we know that 3 divides, or let's use a 4. Okay, 4 divides what 4 divides 8. Okay, and we know that 4 also divides what divides 4. All right, so notice that here 8 is greater than 4, therefore the 4 will divide what 8 minus what 4. Okay, let's give another example. Okay, let's say that 3 divides 12. 3 divides 12, that is true. And also 3 divides what? Divides 6. And of course, will 3 divide the difference between 12 and 6? Okay. That 12 minus 6 is 6. And 3 divides what? 12. So that is why we have this property. Okay. Now notice that the next property is similar. Okay. Similar to what the 4, except that d doesn't what divide what b. So that's the only difference. Where d divides a, it doesn't divide b, but and then what a is greater than b. Now, of course, it will not divide their difference. Okay, so you have what 4 divides say 12, and we know that 4 doesn't divide what 7. Of course, we know that 12 is what greater than 7, which satisfies that condition. Therefore, we know that 4 will not divide 12 minus what? Minus 7. Okay, 4 will not divide what? 12 minus 7. Okay, and then the last property is that, okay, it also follows from the previous property, but when you switch the condition where it is divisible or is not divisible, then it won't divide. For example, as we say, D doesn't divide A, and then D divides what? B, which is the opposite of what? The previous. Again, the same condition is true, that A is greater than what? B. Then the D will not divide the difference between what? A and B. Okay, so let's give an example. All right, 4 does not divide what? 15. We know that is true. Okay, because you get a remainder. And then we know that 4 divides what? 8. 15 is greater than 8. Therefore, can we see that 15 minus 8 is be divisible by 4? Of course, 15 minus 8 is 7, and then 4 doesn't divide what? 7. Okay, so here is a question. It said, is the number 1737 divisible by 17? Okay, apply the second property. Now, what is the second property, which is here? The second property is that, okay, if I can split A, D divides what? A, and D divides B, then D will divide what? Their sum. So that means that if I can find, write this 17,734 as I write a sum of two addends, that 17 divides each of them, then I can find the answer to this what? This problem. Okay, so let's look at it. We know that 1734 is the same as 1700 plus what? 34. All right, so then since we know that 17 will divide each of them, okay, we know 17 divides 1700. It goes in how many times? That is 100 times. And also, we have for 17 will divide 34, which is what? Which is 2. So then that means that the 17 will divide what? 17 divides the 1700 plus what? 30 what? 34. Okay, which in this case will be equal to what? The 100 plus 2, which is 100 and what? 102. Okay, so we know that 17 divides what? 1734. What? It goes into that to 102. In other words, the 102 and 17 are what? Factors of 1734. Okay, now the other example is looks at, can we state the following, whether the following are true or false, and can we explain why? Okay, does 4 divide 20? We know this is true, right? This is true. Why? Because 4 times 5 is equal to what? Is equal to 20. Okay, 4 times 5 is equal to 20. What about, does 0 divide what? Divide 2. Okay, does 0 divide what? 2. Of course, this is what? This is false. Why? Because, all right, there's no what? There is no C, okay, such that what? 2 is equal to C times what? Times 0, or 0 times C. Okay, so there's nothing like that. Okay, so because of that reason, 0 doesn't divide what? 0 doesn't divide what? Any number. There is 0 divide what? 2. Remember, in the section 3.5, we said that this is what? This is right. It's like writing 2 divided by 0, which is undefined. Okay, that is why this is not true, or that is false. Now, is 0 even? Is 0 an even number? Okay, if 0 is an even number, then it means that 2 divides it without a remainder. So this is true. 0 is an even number. Why? Because 0 is equal to what? 0 times what? 0 times 2. In other words, we are saying that 2 divides what? Divides 0, which we can write it as what? 0 divided by what? 2, which is what? Which is 0. Okay. So what about the fourth one? If 3 divides x plus what? X plus y. Then 3 divides x and 3 divides what? 3 divides y. Now, I want you to know this. Compare this to this example that we just did. Okay. So what we did was that in their example, we found two numbers. When you add two addends, when you add, you get what? Our number 1,734. So is this always true that if a number divides each of the addends, then it will divide their sum? That's going the other way. Okay, let's find out. This is not always true. It's not always true. Okay, this is not always what? True. So we say that this is what? This is false. Why? It is not always what? Always true. Okay, why? Okay, let's give an example. Now I know 3 will divide what? 9. Okay, this is true. 3 plus 9 plus 3 plus 9, which is 12, and 3 divides that. Because why? 3 divides 9, and 3 what? Divides the same itself. Okay, what about this same number, which is 12? I can express 12 as what? 10 plus what? 10 plus 2. Does 3 divide 10 plus 2? Okay, that is true. Okay, this is true. This is 12. But does it mean that does 3 divide 10? And does 3 divide 2? This is not true, and that is not true. So that's why we said that this is what is always not the case. Okay, it's not always not the case. So if you are, suppose I was given 12 and I want to find out whether it divides just the two addends, then I need to express that 12 into numbers that are divisible by what? The divisor, which is 3 in this case. Okay, it works for the previous example, but if you express the 1,734 differently with different numbers that are not both divisible by 17, in this case, will not work. Okay, so now let's talk about the divisibility test for 2, 5, 6, and so on and so forth. Okay, now write this down. If for the divisibility test for 2, 5, and 10, okay, if it is 2, then the last digit is what is even. That is, it could be 0, 2, 4, 6, and 8. Now, if it is divisible by 5, the last digit must be what? 5 or 0. And then if it is divisible by 10, the last digit of the number is what? Should be what? Should be 0. Okay. Now, the test for 4 and 8, it says that the last two digits is divisible by what? 4. That means it is what? The number is divisible by 4. And if the last 3 digits, okay, is divisible by 8, then the number is divisible by what? By 8. For the case of what? 3 and 9, you sum all the digits, and if it is divisible by 3, then we say that the number is divisible by 3. Similarly, for what? For 9, the sum of all the numbers is divisible by what? 9. Then it is what? Divisible by 9. Okay. All right. Now let's go to the other tests. Okay. Now before we do that, let me explain this diagram. Now this diagram says what? Numbers divisible by 2, numbers divisible by 4, numbers divisible by what? By 8. Now going from inside out, okay, going from inside out is true. Okay, what does it mean? A number that is divisible by 8 is divisible by 4. It is also divisible by what? By 2. By going from outside to inside, it is what? It is false. Because a number that is divisible by 4 does not mean it's divisible by what? By 8. Okay, example. We know that 4 divides 4, but we know that 8 does not divide what? Does not divide 4. Okay, also a number divisible by what? 4. Okay, divisible by 2 does not mean it is what? Divisible by 4, or even divisible by what? 8. For example, we know that 2 divides what? 2 divides 2, but 4 doesn't divide what? 2, nor 8 divides what? Divides 2. Okay, on the other hand, 2 divides 8, but remember, see how we write that. Okay, now what is the test for what? For 6, and then for what? For 11. Now the test for 6 is that if the number is divisible by both 2 and 3, then it is divisible by what? By 6, because we know 6 is equal to what? 2 times what? 2 times 3. Okay, 2 times 3. So it means that if a number, okay, if two factors of a number are both divisible by a certain number, that means that their product, that number is divisible by their product. Okay, now in the case of 11, okay, you want to know using the base 10 place values, like you write in an expanded form. All right, you have to find the sum of all the digits in places that are even powers of 10, and then minus those that in the places that are what? Odd powers of what? Odd powers of 10. Okay, so in this problem, the next example, we are given the 27,466, 63,223. All right. So is this number here divisible by 2, 3, 5, and so on up to 11? Okay. So for A, let's do for A. Is this number divisible by what? Okay. We look at the last digit must be what? It must be an even number. So the answer is what? No, because 2 does not divide what? 3, which is the last what? The last digit. Okay, it must be even. So we say that the number here, 27,463,223, is not divisible by what? By 2. Okay, is it divisible by 3? Is it divisible by 3? All right. Now B. Now for the divisible by 3, we have to find the sum of the what? Of the digits. So you got to find sum of the digits. Okay, which is what? 2 plus 7 plus 4 plus 6 plus 3 plus 2 plus 2 plus 3. And this is equal to 20 what? 29. Okay, is equal to 29. Okay, means that we got this right. We have what? That is 9, 13, 19, 22, 24, 26, and 29. Okay, but since 29 is not divisible by 3, we say that number, okay, our number is not divisible by 3. So the answer is what? No, since what? Since 3 doesn't divide what? The 29, which is the sum of what? All the digits, like that. Okay, what about C, which is 5? That's 5. That's the number. That's 5 divides what? The number. Does it divide it? No, because the last digit is not 0 or 5. So you say that no, since, okay, since what? Last digit is not 0 or what, or 5. Okay. Okay, D, is it divisible by 6? All right, the answer will be no, because if it's divisible by 6, then it must be divisible by what? Both 2 and 3. So since 2 does not, the number is not divisible by 2 and what? And 3. All right. What about E, which is a 8? Okay. Is it divisible by what? By 8. I also do divisible by 4. Okay. So is it divisible by 8? Okay. First, we look at the last 3 digits, which is what? 2, 2, 3. So the question is that, does 8 divide what? Divide the number that. Now, of course, if you use our calculator, okay, which is 2, 2, 2, 3 divided by what? 8, it is not possible. You have decimals. So we say that it's not divided by what? So your answer is what? No, because 8 does not divide what? 2, 2, 3. What about 4? Is it divisible by 4? Divisible by what? By 4. Okay, I didn't put it there, but I can include it here. Okay, for 4, you look at the last 2 digits. In this case, will be what? Will be 23. So does 4 divide what? 23? No. So we can say that the number is not divisible by what? 4, since what? 4 does not divide what? The last 2 digits, which is what? Which is 23. All right. Now, let us look at the that is E. Let's look at what? The F. Okay. Is it divisible by 9? All right. The sum of the digits, remember, is what? Is 20 what? 29. So, of course, 9 doesn't divide what? 29. So the answer is no, with the same reason, since 9 doesn't divide what? 20 what? 29, which is similar to the part B, which is for 3. Okay. Now let's go to 10. All right. Is it divisible by 10? And is it divisible by what? 11? Those are the last 2. Okay. So our number is still here. Okay. Let me write, is it divisible by 10? Then it's what? It's G. Is it divisible by 10? Okay. Don't forget the number is still here. Okay. Is it divisible by 10? No. What's the reason? No, because the last digit is not what? It's not 0. Since the last what digit is not what? 0. Okay. Then it's 11. 11 is where we find the sum of what? The even powers, and then what? The sum of the odd powers of 10, and then find the difference. So let's look at what? H. So first we want to write the number again. I need to write it carefully here. 27, 4, 6, 3, and 2, 2, what? 2, 2, 3. Okay. Now I will use we have to write the, what do you call it? The even powers, like the place values. So this is 0, 1, 2, 3, 4, 5, 6, 7. Now notice that 0 is an even number. Okay. So all the digits that are what? Even powers. So first we look at what? Sum of what? Even powers of 10. Now these are, okay, that is 0, should be 0, 2, 4, and 6. So the digits are 3, 2 is what? Is 2, plus the 4 is 6. The place for the 6 is what? Is 7. Okay. So when you add this, you get what? You get 18. And then we do the sum of what? Odd powers of 10, which will be the places for 1, 3, 5, and 7. So we get what? 2 plus 3 plus 5 is for 4, and then 7 is what? 2. So when you add this, you get what? 5 plus, that's 6 plus 5 is what? Excuse me, is 11. Okay, so let's find the difference. The difference between these two numbers, the difference is what? 18 minus 11 is equal to what? Is equal to 7. So the question is that we know that 11 doesn't divide what? Divide 7. And therefore, the answer to the question is what? Is no. The reason is, as I stated, 11 doesn't divide what? Divide the sum, the difference between the even and odd powers of what? 10. Okay, so I thought I would give an example. Maybe this one it will be divisible by what? By 11. Okay, so that we see the difference. Now we do the same thing. Okay, let me use a different color. You write the place values to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then what? And 10. Okay, so again, like we did, the even powers of 10. Okay, the sum of what? Even powers of 10. Okay, which will be 3, starting from the 0, 3 plus 5. Okay, 3 plus 5, and then what do you call it? That's 0, 2, and plus 6. Okay, the place of 6 is what? 9. The place of 8 is 7. A place of what? 10 is what? Is 5, which will give us what? 35. So add everything you know. And then let's look at the odd powers of 10. Okay, in this case will be the places for 1, 3, 5, and so on. So that is what? 8 plus 4. Okay, plus 3. 7 is what? 2. Plus 9 is what? 7. Okay, so you have what? 4, 8 plus 4 plus 3 plus 2 plus 7. And that is what? 20, what? 24. So let's find the difference. The difference will be what? 35 minus what? 24. And this is equal to 11. And of course, now since 11 divides what? 11, which is the sum, which is here, this 11. Okay, the number is divisible by what? By 11. Okay, it's divisible by what? By 11. All right, so here's an application. Now, of course, maybe you are saying that, oh, do we do this in the second grade? No, of course. These are very huge numbers. Second grade, you don't want to deal with them. But we start teaching this in second grade. Doesn't mean everything that we have covered is done in second grade. That would be just too much for them. They can't even understand, I mean, in the thousands, let alone in the 10,000s and millions. No, but I'm talking about this could be done like a sixth grade or a fifth grade or even an eighth grade. All right, eighth grade students, give them huge numbers. Eighth grade, for example. Now, this application is, of course, in the middle school for sure. All right, so let's look at this. This is, suppose you are a store manager and an invoice for 72 calculators. Okay, but the first and the last digits of the receipt are illegible. Okay, it's illegible. All right, then the manager, as a manager, you read, this is what you read. So the question is that how do you figure out the first and the last digits? Okay, and then we want to know what are the missing digits, and what is the cost of each calculator. You are a store manager. So how do? You didn't put in the computer. These days, we got everything stored on the computer. You don't need to do this. But if a customer comes with what? With this receipt and doesn't remember, how do you figure it out? Okay. You can use the visibility to do that. Okay. Now, before we go into the solution, I want you to know that if a number is divisible by what? By 72, then it is it is also divisible by the factors of what? Factors of 72. Okay, factors of 72. Now, if you want to express into the numbers that we have tested their divisibility, we can look at 8 and then 9. All right, 8 and 9. 8 times 9 is what? Is 72. Okay, so that's what we want to look at. Now, first, we are given this number. Okay, this is the amount. Okay, and we have what? 67.9 and a box. These are missing. Okay, now this is dollars. Now we can write this, let X. Okay, you first let X and Y be the first and last digits. Okay, so then we can write this as X67.9Y. Okay, dollars. Now we can convert this to, because we don't want to deal with decimals, so we multiply by 100 and write this as what? X679Y cents. All right, which is that. So the question is, this becomes a whole number now. How do you figure the word X and Y? Okay, now since we have what? 72 calculators, we got 72 calculators. All right, now 72 is equal to what? 8 times what? 8 times 9. Okay, so our problem, we want to find 17 in whether 17 divides what? 679 what? 9y. Okay, but since we have 72 calculators, we'll write the 72 as a factor of our two numbers, 8 and 9. So now we're going to figure out if this is the case, then 8 should divide what? This number, and as well as what? 9. All right, so first let's consider, okay, consider 8 dividing the number X679Y. Now if 8 divides the number XY, then it must divide what? The last 3 digits. Okay, so that means that 8 must divide what? 79Y. And then you must know that Y must be what? Must be even. Okay, must be an even number. Must be an even number. All right. So then we want to look at the possible values that the Y can be. So first, let's look at the possible values. Okay, we can have for 790, 792, 794, 96, and then 798, 798. Okay, now among these possible values, which of them is divisible by what? 8? If you check, all right, 792 divided by 8 is what? 99. But if you check the rest, okay, 790 divided by 8, it doesn't go in evenly. As well, let's check the last one, 798 divided by 8. So it's 99.575. Okay, so this, none of them except what? The number that I circle. All right, so it means that the last what? The last digit must be what? Must be it. So since only, okay, 792 is divisible by 8, okay, y must equal what? Y must equal 2. So now the number becomes what? X6792. So now we need to figure out what the first digit is. Okay. Now this first digit 9 9 must divide what? That number. Now, if remember, if 9 divides the number, that means that the sum, it divides what? The sum of the digits. Okay, so let's find the sum of the digits of what? Of the number. Okay, which are x plus 6 plus 7 plus 9 plus 2. Okay, and that gives us what? X plus what? 24. X plus 24. So if x plus 24, then what is the possible value of what? Because this must divide, this must be true. Okay, it's not that you are checking. The number must be divisible by what? By 9. If must be divisible by 9, then what would be the possible value of x? Okay, x could be 0, 1, 2, up to 9. The only number that will work is what? Is 3. If this is 3, you get 27, and 27 divides divisible by what? By 9. Okay, therefore, so we say that if 9 would divide, okay, x plus what? 24, then x must be equal to what? Is equal to 3 only. Hence, what we have the invoice. The invoice must be how many? It will be what? 367.92 cents. Okay, that's our invoice. That is, the missing numbers are what? Are 3 and then 2. The first is 3, the last is what? Is 2. Then what is the cost of each? Cost of each calculator will be, that is, you divide this by what? By 9. So by 72, I mean. Divided by what? 72. So use your calculator. That comes to what? $5.11 what each. $5.11 what each. That's the answer. Okay. So that brings us to the end of what? This that brings us to the end of this video. I hope this is helpful. Email me if you have any questions. Thank you.